One type of valve that's commonly used in process systems to start and stop flow is the gate valve. Gate valves are designed to be used primarily for on-off purposes. They operate best in either the fully open or fully closed position. Gate valves are often used to isolate equipment. For example, these gate valves are in the suction and discharge lines of a pump. Shutting the valves isolates the pump from the rest of the system. Gate valves are also used in situations where the valve position seldom changes, such as a drain valve on a tank. In a situation like this, the valve would be closed most of the time. Gate valves are pretty easy to identify because they have relatively long bodies and long valve stems. On a piping system diagram, a gate valve is usually represented by this symbol. If the symbol looks like this, it means the valve is normally open in the system. If a symbol is filled in, it means the valve is normally closed. Other types of notation may also be used to show valve positions, such as the letters NC for normally closed and NO for normally open. Now that we've seen the symbols for a gate valve, let's look at the valve's parts. A gate valve consists of a valve body, a seating area or seat, a disc, a bonnet, a stem with a hand wheel attached to it, a stuffing box, packing, and a packing gland with gland nuts. The disc is usually wedge-shaped and fits snugly in the seat when the valve is closed. When the disc is completely raised, flow is straight through the valve with very little obstruction. The stuffing box holds the packing in place, and the packing gland fits into the top of the stuffing box. The gland nuts are used to tighten down on the packing gland. As I said, gate valves are normally used in on-off applications, but in an emergency they can be used to throttle flow. However, long-term use as a throttling valve can damage a gate valve. In many types of gate valves, when the disc is raised slightly, fluid flow through the valve creates turbulence, which causes the disc to swing from side to side, banging or chattering against the seat of the valve. This chattering will cause wear on the seat and disc, and eventually the valve will not shut off flow when it's completely closed. One type of valve that's commonly used in process systems is the globe valve. A globe valve can be used as an on-off valve to isolate components and as a throttling valve to regulate the flow of fluid to components. Let's examine the construction of a globe valve to see how this is possible. A globe valve consists of a globe-shaped valve body, a seating area or seat, a bonnet, a disc, a stem with a hand wheel attached to it, a stuffing box, packing, and a packing gland with a gland nut. Fluid flow enters a globe valve here and exits here, making several right-angled turns as it passes through the valve. Globe valves are normally arranged in a piping system so that the higher pressure side of the piping system is acting under the disc of the valve. This makes it easier for an operator to open the valve. As you can see, as a globe valve is opened, the entire disc and seat are exposed to the fluid flow. This design feature prevents uneven wear of the seat and disc. In addition to the regular seat, some globe valves, like some other types of valves, have a back seat. If we look inside the bonnet of a globe valve that has a back seat, we can see that when the valve is fully open, the top side of the disc seats against the back seat. This prevents the packing of the valve from being constantly exposed to piping system pressure and reduces the likelihood of a packing leak. You can usually recognize a globe valve by its globe-shaped body. However, not all globe valves look like this one. Here is another type of globe valve called an angle valve. It's easy to spot because of its globe-shaped body with piping connections at a right angle. Angle valves are used to change the direction of fluid flow. This is another type of globe valve called a needle valve. Needle valves are usually smaller than other globe valves and are designed to give fine control of flow in small diameter piping. A needle valve has basically the same parts as other globe valves, but its disc is shaped differently, like a needle. The needle extends deep into the seating area of the valve. A small movement of the stem causes a small, gradual change in the flow rate through the valve. This gives the needle valve an extremely fine throttling ability. On a piping system diagram, a needle valve generally looks like this. An angle valve generally looks like this, and a globe valve generally looks like this. If the symbols look like this or have the letters NO beside them, the valves are normally open. If the symbols are filled in or have the letters NC beside them, the valves are normally closed. The symbol may also be shown partially filled in. When the symbol is shown this way, the valve is in a throttled position. Plug valves are generally used for on-off purposes in situations that require quick valve operation and a tight shutoff, such as in this gas line. Plug valves can usually be recognized by their cylindrically shaped midsection and flat bottom. On a piping diagram, the symbol for a plug valve generally looks like this. If the symbol looks like this or has the letters NO beside it, then the plug valve is normally open. If the symbol is filled in or has the letters NC beside it, then the valve is normally closed. A plug valve consists of a valve body, a seating area or seat, a stem with a handle attached to it, packing, and a packing gland with packing gland bolts. Instead of a disc, a plug valve has a plug to control flow through it. The plug has an opening straight through it, and it rotates inside the valve body. The plug's position is adjusted by turning the handle. When the opening in the plug is in line with the valve's inlet and outlet, the valve is fully open. To close the valve, the plug is turned so that the opening is perpendicular to the valve's inlet and outlet. So a plug valve can go from fully open to fully closed with only a 90-degree or 1/4 turn of the handle. Also, the handle on a plug valve is usually aligned with the opening through the plug, so that the handle position indicates the valve position. If the handle of the valve is in line with the piping, then the valve is open. If the handle of the valve is perpendicular to the piping, then the valve is closed. For complete shutoff of fluid flow, the plug and seat must make a close fit as the plug turns in the valve body. The close fit is needed to avoid leakage around the plug. But because of this close fit, turning the plug can gradually wear out the plug and seat. If either one wears out, fluid flow won't be shut off completely when the valve is closed. To minimize the friction between the plug and the seat, many plug valves are lubricated. Some plug valves are equipped with a fitting on top of the stem through which lubricant is supplied to the plug. Now let's take a look at another type of plug valve, the multi-port plug valve. A multi-port plug valve has additional piping connections and a different type of plug. Instead of a plug with an opening that allows fluid to pass straight through the plug, a multi-port plug has an L-shaped opening. Here's an example of a three-way multi-port plug valve. When the plug is lined up in this position, fluid enters here and exits here. But when the plug is moved to this position, fluid enters here and exits here. Some multi-port plug valves have more than one L-shaped opening in their plug. Here is an example of a plug valve with two L-shaped openings in its plug. This type of multi-port valve is called a four-way valve. It's commonly used to change flow through a piping system. Multi-port plug valves usually have L-shaped markings on their valve handles to indicate what position the valve is in. The L on the handle is aligned to the shape of the opening through the plug. Three-way plug valves usually have one L, and four-way plug valves usually have two. By comparing the position of the L's to the position of the piping that the valve is attached to, the direction of flow through the valve can be determined. Ball valves are commonly used for on-off purposes requiring fast valve positioning in process systems. A ball valve consists of a valve body, a stem with a handle attached to it, a ball with an opening straight through it, a seal around the stem that prevents leakage along the stem, and two-part ring-shaped seats, which are commonly called wipers. A ball valve can be opened or closed by turning the handle 1/4 turn. The handle is usually aligned with the opening in the ball, so that valve position can be determined by the handle position. The body of a ball valve may be either cylindrical or round in shape. On a piping system diagram, a ball valve symbol generally looks like this. If the symbol looks like this or has the letters NO beside it, then the valve is normally open in the piping system. If the symbol is filled in or has the letters NC beside it, then the valve is normally closed. Butterfly valves are used for a variety of purposes in industrial plants. Typically, butterfly valves have round, relatively thin valve bodies. Because of this, they take up a lot less space in piping than many other types of valves. A butterfly valve consists of a valve body, a seating area or seat, a disc, a stem with a handle attached to it, a stuffing box, packing, and a packing gland with gland nuts. The disc of the butterfly valve is just slightly smaller in diameter than the inside of the piping in which the valve is installed. The disc is also relatively thin and offers little obstruction to flow when the valve is fully open. The disc is attached to the stem. The stem is used to rotate the disc when the handle is moved. The flow rate through the valve is adjusted by changing the angle of the disc. The butterfly valve requires only a 90-degree movement or 1/4 turn of its handle to go from the fully open to the fully closed position. The handle is usually aligned with the disc so that when the handle is in line with the valve's inlet and outlet, the valve is fully open, and when the handle is perpendicular to the piping, the valve is fully closed. On a piping system diagram, the symbol for a butterfly valve generally looks like this. If the symbol has the letters NO beside it, then the valve is normally open. If the symbol has the letters NC beside it, then the valve is normally closed. In this topic, we looked at how gate, globe, plug, ball, and butterfly valves are constructed and at how these valves operate. We also saw how you can identify these valves in piping systems and on system diagrams.